let's say I have this kind of project, and as you can see, it's only one floor. And generally, I will need to have rooms like this. So let's say this one is corridor. This one, let's say this one is office. One, office two. Before we do the Corey load analysis, we need to see rooms. Actually, we need to see spaces. Spaces are different than rooms in Revit. I will explain why. Let's say this one is storage. This one, let's say, is WC. This one is what? Open office. So we have all these type of spaces here. Now, before I continue explaining here, let's see something here. Let's say we have another two spaces like this. I will create between them one wall. Now, in order to understand what is the difference between room and between space in Revit. So if I press RM or I go and I click here, so this is one room. There is another thing, if I go to analysis, this one is very similar. This one, as you can see, place analytical space to account the entire volume within the model. This includes rooms, plenums,
Height.
and chases.
Includes height, is it?
Sorry?
It includes height, is it?
No. It's more complicated than that. I will explain. So when you insert, it's asking you to bring a tag because there is no tag is connected to this. So you click yes. And then it will show me my library. I have to go to mechanical. And there is this one, space tag. Click OK. Now I can bring it here. Look the difference now. When I select this space, first of all, it looks blue. If I select this one, it also looks blue. But look the different parameters here. Room, the parameters are very basic, and usually architects, they work with this parameter, with these basic parameters regarding area, perimeter, volume. But look when I select the space, even though it looks similar, but when I select it, average estimated illumination, room cavity ratio, lighting calculation, work plan, ceiling reflectance, wall reflectance, floor reflectance, design HVAC load per unit or per what? Or per hour, per area. You see, too many parameters. Mechanical flow, supply of airflow in this space. For example, these things are very related to mechanical engineers. The energy analysis, things regarding to energy analysis. This one, if it is plenum or not. So this plenum is like a space between the slab and the ceiling. You know that space where there is a slab and ceiling? That one, they call it plenum. And of course, generally, it's not air conditioned and it's not air ventilated. So if your space will behave in that way, you select this one if you have ceiling, because I can create a space even in the section normally. If when I have a section, I can see between the ceiling and the slab. I can highlight that one as a premium space. Anyway, you see this one, condition type. Is it heated and cooled? Is it only cooled? Is it unconditioned? Is it vented? Is it naturally ventilated? So for example, in Malaysia, generally, we will use cooled if it is air conditioned. It's not heated and cooled. And sometimes the corridor, if it is naturally ventilated, it should be naturally ventilated. So this vented, what do you mean by vented?
Means mechanical
Yes,
fan.
yes. And as you can see, there is space type. Remember, now we are selecting this space. So space type, what do you mean by space type? Space type, is it?
User.
Yeah,
Space user.
the function of the space. If I click, as you can see, the good thing, there is a library which shows you all the space types here. So this means because each space type, according to certain standards, for example, let's say this is an active storage. Look, for example, area per person is 33.3 meters square in active storage. So according to standards, sensible heat gain per person and latent heat gain. If you remember, last time we talked about this sensible and latent heat. So basically, sensible is the heat that you measure using your thermometer, but latent is the heat which can be consumed in the time between change in the aspect or the characteristic of the material from liquid to vapor or anything. Light to low density. So it's like according to standards, so it's 8.660 watt per meter square, loud power density. So it's like you just select the space type and all these parameters will change according to the space type. So this space type is very important. For example, here I have open office space and here corridor. This means in order to get the exact cooling loads, the amount of heat that we need to remove, space type should be assigned. But now I cannot assign because these are rooms. They are not space. They are not what? They are not space elements. Again, let me go back here. So I think you understand what is space type. What is it? Yeah, space type. And there is construction type. What is construction type? Always.
Perhaps like RC or like steel structure.
Yeah, things regarding materials. And in any, almost even in IAS, when it comes to an IAS VE, that one integrated environmental solution. Like it's like design builder, and when it comes to material, they call it construction type. So if we click here, as you can see, there is always this small box with 3 dots. So first of all, it's saying, it's like you can create different scenarios here. Now, this one is very important. So by default, analysis properties are generated from information in conceptual types. Properties of schematic types are used when override is selected. Conceptual type is any material you insert here, it will be considered. However, if you want to use schematic type, so these information, they are schematic. It's like a template which will generalize the construction materials in your building regarding, for example, roofs. If you are not happy with the conceptual type, or so you can just override it. So you tell Revit, forget what is happening in the model and consider the roof is using this one. So actually, this one I have to. Yeah, this means I have to override here. I'm not sure why I cannot override here.
You mean this is default, is it?
Yeah, but it depends.
Construction one is new lah, means.
Yeah, this one, yeah, it's a new one, yes.
Okay.
So, but you have to click override if you want to apply this. You have to click override and you use the one that you, as you can see,
choose.
At roof with U value this and this, etc. So there's many options here. So if you use this, for example, now, what will happen? Revit will consider your roof has this U value. Revit will forget what is happening in the real model here. It will consider this to do the calculation. So these ones, they are schematic properties. If you want to use the conceptual type, you should not override here. Because if I override this one, it will be used. Okay, so I think you have an idea. So things regarding material, so the composition, you value at all these parameters. And there is, as you can see, people. If I click edit, I can select by space type, or I can make it
By
specified.
race.
No, by race? No,
Chinese people.
no. This one, as you can see, you can keep it by space type. If you keep it by space type, it means people, because if I go to space type, there is something regarding people. As you can see, there is area per person, as you can see here. It's 28. So this one, normally it's regarding people. There is, yeah, this one, I forgot about this one. I didn't show you this before. Occupancy schedule. So if it is an office, for example, if I click here, you see these details. So basically, so this time, as you can see, there is 0%, 12 a.m., 0% of occupancy of people. So at 7 a.m., 10% they are there. 8 a.m., 20%, 9 a.m., 90%. Yeah, here there are the PMs. Basically, we consider PM more here. So as you can see, 2 p.m., for example, 90% are here, as you can see. Look the diagram. Of course, this one you consider, you select it depending on the space type. It's not, you should not select an office building, an office space type, and then you make the occupancy of a toilet, for example. So it's not logical. So things should be tally. Of course, you still can modify these things also. So you can even create your own, because Revit is trying to give you some kind of a library, but Revit cannot give you everything. Okay. But the good thing, you will not need to change, almost you will not need to change anything. You just select the space type, any space type, and apply it. That's it. No need to, it's good to see what is happening here, but for the sake of this assignment, no need to do changes. What else? If I go down again, so remember, these are important. Construction type, people, no need to change it because you just keep it by space type. And there is electrical loads by space type also, no need to change. If you want to make it specified, you can make it as you want. So the density of watts per meter square. You can increase, you can decrease. Okay, so now you know what is the difference between room, which is usually used by architects, and space element, which is usually used by mechanical engineers. All right, but now let's say you did, this is what you did in your project. You have rooms now. How to change them to spaces? What you have to do, actually, you have, for example, this is level 1. I will duplicate it like this. As you can see, when I duplicate it, I will not see the room elements, even though I know they are here. So I call this, for example, level 1, let's say add hashtag spaces. Now, if I go to schedule, as you can see, there is space, there is room. If I go to room, All right, before I do this, let's bring the spaces. I forgot to bring them. So from analysis, I will bring space. I will put one here, one here, one here, one here, one here. As you can see, I have only 6 spaces. Imagine if I have too many spaces, I cannot know, I don't know which kind of space is this. Is it office building? Is it office space? Is it storage? I know it's storage, this one is open, but if there is too many, I may forget. That's why it's good to create schedule, and you go here, and then you select space elements. So the most important things is space name, name and area and condition type. Normally there is something called condition type, construction type, to make things organized. Instead of selecting each space and you change by itself, so you do this thing. And design column, what else? Condition type, area, name, maybe number if there is number. Okay, but before I apply, as you can see, I can still select here, and I can see rooms. You will understand why I can see rooms. Now with rooms, I can bring room name, and I put it like this. So in this schedule, this focus here is very important. I have the name of the space, number of space, area of space, condition type of space, construction type of space, and I have room name of rooms. Look what happened when I click OK now. Are you following, Daniel?
Yeah.
As you can see, now I know this space is storage. I know this space is open office. This one, I have to remove it because it's the one. Okay, let me remove this. When you see it's not placed, you just can remove the line. So these are my 6 spaces. I can now start, since if I go to level 1, I can see spaces like this. Now what I can do, I go to analyze. There is this one. Where is it? Space naming. You see, there is this one. This tool will allow you to change from rooms, name and numbers, to spaces. And I click OK. Look what will happen. Automatically, everything will change. You see? So this tool is allowing you not to waste too much time. So automatically you will get the name of the rooms. After that, it's very important. I go back to the schedule, and based on the naming, I try to find the condition type of for example, this one is storage. Normally it's not, let's say it's vented. Office should be cooled. WC, let's say it's vented also. Corridor, let's say it's not naturally ventilated, or is it naturally vented only? Naturally, okay, naturally. And office, it should be cooled, and this one should be cooled. Same thing, I can start changing. Instead of going to the model and change space by space, I use this schedule to show storage, what is the construction type. It depends on you. It depends on you here. If you want to use the building element material, for example, if you already assigned material, because now I don't have any material, remember, by default. So this means I have to assign materials according at least to the typical standards here in Malaysia, what type of walls they use, like the base things. If I want to use the information of this kind of information in the model, I just keep it building here. However, if I want to test options without answering the material in walls, I can go to storage, for example, and I'd say that the exterior wall, I can apply another one. So I apply this construction, for example, exterior walls, there are something here. There are any kind of options I want. Another thing, before I forget, I forgot that when you go to the level here, you are chatting, right? So when you select a wall inside here, I click edit type. You see the function parameter is exterior, and it should not be exterior, this one. If I keep it exterior, it can make mistakes, so you have to be careful. This one should be interior. Same thing, this one, I'm sure it's this means I have to duplicate and create another wall. So to exterior. You should not make this kind of mistakes, especially when the material is assigned, because the exterior face generally will play different role from interior face. The second issue is this. This one, it shows you the exterior direction of which is facing. As you can see, normally this one is not exterior, it's interior. This means you have to click in order to make it exterior. These small things, if you don't respect them, they will make the output wrong. So basically you have to go through all these walls and you make sure they are interior. This one should be exterior because, so normally this one. All right, we still have only 10 minutes. So after doing all these kind of things, you have to go, when you go to analyze, you click, you see that it's heating and cooling loads. Well, here I will press OK. You have chosen to compute all the areas in the computation system, which means Revit approximate the volumes for space. Do you want to enable the areas? Yeah, okay. I will press OK. When you press OK, you will see the zones, or not the zones, at least the spaces that we have assigned, and you can even you can see it like this. Now, one of the things which is very important is the location of the project. If the location is in Boston and you are doing your Boston, actually, you know, they have snow for 3 months. It's snowy, so all the output will be wrong. So the location of the project is very important. So you have to select Kuala Lumpur. Since your project is in Kuala Lumpur, you can take this small house. You can take it to Kuala Lumpur, or you can search here. You write KLCC, or I think you know how to do that. So ground level is level 1. Office, silver space tolerance, use function parameter. So this one, building service, for example. So what type of HVAC systems? As you can see, there is too many types. So in the report, you have to let me know what type of HVAC system you are using. Why you choose this, maybe based on the typical practice. So you have to find out. And this one, schematic type. This one is like, instead of applying the schematic type on only one space, you can apply it on the total project. So if you are planning to do simulation using your building characteristic and materials, you just keep it building here. And this one is regarding the report. Is it simple, standard, or detailed? I will not click, because if I click calculate, I will get the report. It's not complicated, but if there is any mistake in the input, everything will be wrong. The building type also. Is it an office? Is it, what is it? If I go now to details, as you can see, I have this default. This one, we call it zone. So zone, it has, as you can see, these all spaces that we did. And as you can see, again, spaces, we can change the building space and construction type from here. Well, and I can also, for example, I select storage and I can see analytical surfaces. I can highlight, for example, only, I can isolate only the storage. As you can see, Revit has detected the different surfaces of this space. So basically, as you can see, there is a floor which with this color, and windows and all these walls. Now, if I click plus, I will see exterior walls. So it has detected also the orientation. So this one normally is in the west, and the windows. We have two windows here. Because Revit knows it's very important. Too much heat will go through the window, so that's why they are making detailed things looks like they are detailed. Interior walls. We have 3 interior walls, is saying. This wall has plus because it contains 2 windows. You see things how can be very complicated, even though it's very simple project, but too many layers of information here. Ceiling, same thing. Even though I didn't insert a ceiling, but Revit is considering like the surface of that slab, the below surface, as a ceiling. And floors. So this is the one. Same thing for open space. So all these things, they are inside. I still have only 4 minutes before, because I almost finished here. Yes, so same things, remember them, you can change them from here. I think this is all. Now what we have to do, for example, we keep it standard, the report type, and we click on calculate. So this one, it will not take time. You will get a detailed report like this.
Okay.
Now, as you can see, it's too long, but as you can see here, for example, if I go down, component, so these walls, this is how much heat how much heat loads they contribute. Sorry, this one is cooling. So cooling is how much heat we need to remove. So this is how much heat is coming from the walls of the project. This is how much heat is coming from the windows. There is no doors. As you can see, windows heat is more compared to walls. And this is the total. Of course, things, they are not correct because I didn't assign materials. They are still generic. So we need, the data input should be correct. Yeah, things regarding, for example, okay, let's go up. So here, as you can see, the project name and things regarding the temperature of the site. Even winter, we have winter, you know, this is Boston, remember, it's -14. And so this is the total volume, total area of the space. You see, these are the things that mechanical engineers, they really focus on. This, for example, peak cooling total load in what? They use these kind of things in order to dimension their ACMV systems. Things, for example, peak heating load. As you can, apparently we need cooling loads more than heating load in Boston. It's little, well, I know it has winter, etc., but not sure how many, exactly how many months. As you can see, things are straightforward, you can say. So think, yeah, I remember now something, I forgot about it. Please, okay, let me go back to the model. Where is the model? Yeah, there's these zones. Using these zones, it's important to highlight or to connect the spaces which they have the same properties in terms of thermal, heat gain. Like these two offices, they are in the same orientation. So I have to select the first and select the second. Now I created the thermal zone, and then I click finish. And I will create a thermal zone for this corridor because I'm sure it's not air conditioned and it will behave different from these things. So mechanical engineers, they really need this kind of things. I will create, let's say, thermal zone for this. And this one, another thermal zone, another, sorry. Anyway, I did them in one thermal zone. I forgot to finish for each one. But what is the difference now? So these two, if I go to, if I go to heat and cooling, I go to details. As you can see, I have two thermal zones. These thermal zones are very important in mechanical engineers, which they will help them to do all the calculation. Actually, okay, let's stop for